All right, today we're going to be continuing our talk on solutions, but we're going to be talking about a special kind of solution called a buffer. Okay, so a buffer is a solution that is made up of something special. I'm going to write it on the board and I'll describe it later. It is made of a conjugate acid. I don't expect you to know what the word conjugate means. Acid-base pair. So that's like what a buffer is, but what does it do? It withstands changes in pH. A buffer is a solution of a conjugate acid-base pair that withstands changes in pH. We're going to spend a lot of time today, in fact, all of our time today, learning how to make conjugate acid-base pairs. And then next time we'll talk about what a buffer actually does and how it works. On Friday, we'll be doing a lab that will investigate what a buffer looks like. Gents, it's a nice color change lab, and that's always a fun time. Okay, so I just want to talk really quickly about that withstand changes in pH. So normally when you have an ordinary solution, so not a buffer, if you add acid, what will happen to the pH? Will the pH go up or down? pH goes down. And so then what would happen if you added a base to a regular solution? pH would go, pH goes up. A buffer, though, is made with an acid and a base in it. And so when acid is added, the pH will change very little. So if you do the same thing, your pH really shouldn't change very much. Same thing if you add a base. Why do you need a buffer? Because sometimes you are in a situation where you have to add an acid or a base to your substance, but you need that substance to not change pH. So, what would be an example of this? Your blood is a good example of a solution that has a buffer in it. So when we talked about acid and base, do you remember when we talked about all the different things that we drink and we decided that there was nothing that was basic, everything was an acid? And some of them are pretty, they're pretty acidic, the juices and stuff were like around pH of 3. And so if you add an acid to your system, to your body, which is what we're doing when we're drinking our bubblers or our Red Bulls or whatever it is that we're drinking, unless it's water, hopefully, we would be making our whole bodies acidic. We know because there is an acid that dissolves bodies that that's probably not a good look, right? If there wasn't some way for our body to handle the adding of acid, it would be a dangerous situation. So, our blood is made up of a buffer so that when acid is added, it will react with the little bits of base that are in the solution, and so our bodies don't dissolve from the inside out, which is a positive thing. Okay, so now let's talk about the conjugate acid-base pair. conjugate means together. And it really means that you are the same in every situation except for one little difference. Every acid has a conjugate base, and every base has a conjugate acid. Okay, so I think that probably the easiest thing to do is to start with a list of acids and try to figure out the conjugate base. So how do we know if something is an acid or not? Yes, but by looking at its formula. Starts with H. Okay, so I'm going to write that on here. Acids start with H. And so I'm just going to make a list of some common acids. And then I'm going to teach you how to make the conjugate base for each of the acids. Now, the conjugate pair has to have something in common. And so you can't just have an acid and a base and say that they're conjugate pairs, because that's not how it works. A conjugate pair means that it retains some identity of the acid. Okay, so there is a rule for making a base from an acid. To make a conjugate base, you will remove a hydrogen, but only one. And because you have removed a hydrogen, and a hydrogen has a plus charge, how do I know that? I looked at my periodic table. Hydrogen has a plus charge, and so we will reduce the charge of the compound by 1. So if your number was 0, if your original charge is 0 and you reduce the number 0 by 1, what number will you have now? Negative 1. Okay, so the conjugate base for HCl, I'm going to remove the hydrogen, and I'm going to reduce its charge by 1. What is the charge here of this compound? It's 0 because there's nothing listed there, so that's how I know that it's 0. So then it'll just be minus. So the conjugate base of HCl is Cl minus. I'm going to skip the second one, and I'm going to go on to the third one, HI. I'm going to remove one hydrogen, so I'll be left just with I, and I need to reduce the charge, so that will be I minus. Oh, I don't know what happened there. Hang on. Okay. Now, here I have nitric acid. I've got HNO3. I'm going to remove one of the H's, so I'm left with NO3. And what should be my new charge? Now I should be able to go on my periodic table or my pink sheet and see each of these ions and make sure that those are their actual charges. And so if you wanted to look up NO3 on your pink sheet, you would see that NO3 does indeed have a minus charge. But now let's talk about H2SO4. Because the rules for making a conjugate base require me to remove only one hydrogen, I'm still going to have one left over. And so what will be the charge of HSO4? Now, how do you know that you have an acid? Hunter?
Starts with H.
It starts with an H. So, what is true about this formula then? It's also an acid. So it is a conjugate base, but because it still has an H left over, it's also an acid. So we can find the conjugate base of this acid by doing the same process. So I'm going to remove one of the H's, and I'm going to reduce my charge by 1. So I start with -1 and I reduce that by 1, I should get -2. SO4 2- is not the conjugate base of H2SO4. This is the conjugate base of HSO4-. HSO4- is the conjugate base of H2SO4. So if you follow this little rule here, this is pretty easy, but you have to be careful that you're not doing more than you should in one step. Does that make sense?
You have to keep going if you have the H or
no? No. And so if I ask you for the conjugate base of this acid, I just want this. I don't also want this. Okay, so how was this? Are we doing okay? Thumbs up, mostly? How do we know if something is a base by looking at its formula? Mason?
OH at the end.
Yes. Usually. But if we look back at what we just took notes on, are any of these bases in the blue column, like in my blue writing, are any of those containing OH? No. So bases now are more than just ending in OH. So you can write on your notes, but also they are the conjugate base of acids. So how do you know if something is a base now? That's a good question. It's a little bit harder to tell. But usually you will have two substances. So like if you had NO3- and HNO3, how would you know which one is the base and which one is the acid? If I told you that here I have a conjugate acid-base pair, how do you decide which one is the acid and which one is the base? The one that has the more H's is the one that's the acid. Okay, so I'm just going to erase this for right now. Let us talk about how to make acids from bases. To make a conjugate acid is the same thing that you did to make the base, only exactly opposite. So what did we do? We removed an H before, so now we should add an H. And before we reduced our charge by 1, so now we should increase our charge by 1. Okay, so I'm going to make a list of bases here for you. See if you can do any of these on your own. Okay, so see if you can make a conjugate acid from those bases. If you follow the rules, you should be okay. Okay, let's see how you did. You're going to add another H. So we had one, we will add another. And we will increase the charge by 1. So we had a -1 before, -1 plus 1 is 0. So H2SO4 is my answer.
Hi, I just want to show your room up. Are you guys in chemistry class?
Yes, we are.
So I just want Miss Bishop, I just want to show your room up because
No problem.
You can tell your all lives here, right? Right.
Pretty little lamp.
Yeah.
Yeah.
Yeah. It's everything's like. But I just want to. Thanks for letting us interrupt.
No problem. Okay, so ClO3- we add an H. You should add your H to the beginning of the compound. And then we will increase our charge by 1, so HClO3. You ready to go? What's the answer for OH minus? H2O, good. So yes, HOH is your answer, but you're not 7th grade chemists, you are high school chemists, you can write H2O. And then what's the answer for the last one? Oops. Only one H at a time. Only one H at a time, so just HS minus. Okay, I have one more thing to teach you, and then I will give you your homework.
This is where it gets tricky.
This is where it gets tricky, yep. The part where you're like, let me cook, I can do this, is the part where I'll like crush all your hopes and dreams. Alright, so there is a concept that none of you are going to enjoy, and it's called the counter ion. So when we want to have an ion in our thing, in our solution, we can't just have a negative or a positive ion. What would happen if we did? All of the, okay, so imagine that in my blue beaker, I have positive ion, and in my teal beaker, I have negative ion. They would be so attracted to each other that they would, like, have you ever used, like, those really powerful magnets? Keaton, do you remember when we had our neodymium magnets, and then those kids, those little
brats?
Yeah, the ankle biters, they were like goofing with the magnets, and they like crashed together so hard they broke. The magnets broke. And so that's what you would have if you had only positive and only negative ions in these two separate beakers. They would just like smash together, and all of your jars would just be pieces of glass shards. So in order to prevent that from happening, we have to have a counter ion. So if you want Cl minus, you can't just pull a jar of Cl minus off the shelf. There has to be a counter ion. And so we usually use sodium or potassium as our counter ions because if you remember from blue sheet days, potassium and sodium don't ever form a precipitate. They don't ever make an insoluble salt. And so how would you combine Na plus and Cl? What would be the compound that you would make? Correct. Okay, so what happens if you have a base? What happens if you have a base that doesn't look like this, but has a counter ion to balance its charge? In other words, what would that look like? So instead of ClO3 minus, you would have NaClO3. ClO3 minus, but I can't have just the negative ion, and so I put a counter ion on the front. How would you make your conjugate acid from this? Mason, did you have a question?
I was going to ask, how do you determine whether or not to use Na or potassium?
Doesn't matter. It matters so little because they're not going to be involved in the reaction, in any reaction, and so as long as you have one of them, it don't matter. In fact, do you remember when we were doing the salt bridge lab when we had the black and the red leaves? The salt bridge that I had written on your lab is not the one that I put out on the reaction, on the reactant bench because I couldn't find it in the back, and so I just pulled something else off the shelf that I knew wouldn't react. Because its identity doesn't matter, it just has to be there. Okay, so if you have a base with a counter ion, how do you make a conjugate acid? This is actually easier, I think. If you understand chemistry, this should be actually easier. So your rule for this, Elliot, you're giving me percussionist vibes here. If you know your chemistry, so this should actually be easier. This is your rule. Replace your counter ion with an H. And call it a day.
That's it.
So then what's the conjugate acid of that compound?
I agree with that.
That's our rule.
That's your rule. Replace the counter ion with an H. You will only do one. Only replace one counter ion with one H. Only replace one counter ion with one H. So what if you had this as your compound? I do. Can I have 2 of this kind and 1 of this kind, please?
Just one of each. Or
Yeah,
two.
2 of those and 1 of them. Thank you. Damn swimming.
You have circles.
Are you building it?
1. This is the word 1. So only do 1 hydrogen at a time.
Joe, I can't see that.
Okay, so
No, that's not us.
Do you win anything if you win though?
That's not us.
I don't even know.
Something that I decided.
I don't even know, dude, if what there is to win.
Their dip lock is just saying, yeah, no.
That's fine. That's fine. Yeah, your Jeff Black doesn't have to do it. We just need 1 submission from the building. That's it.
Are you doing it?
Yeah, we're gonna do 1. I'm the student government person. I should do something.
Participate.
I can't tell you how much sleep I've lost over this nonsense, though. After we're done, I'll show you the video that the elementary school sent me. You'll love it.
Is it bad?
What?
Are we ever gonna go to like the elementary school and like the update and all that?
Don't know yet. Don't know yet. Okay, so for this example, we're going to take away 1 of the counter ions and replace it with an H. So just take 1 and swap it with an H. How do you know that the H should go first? I'm telling you now. The H should go first.
This is right.
Does that make sense?
Is it always NA?
No, it could be K as well. But it doesn't matter what it is. Mason?
So is the pink sheet going to be just for checking whether or not our ions are?
Yeah. Yeah.
So what are we looking at?
Where'd you do the replacing?
I don't know how to answer that.
Where'd you do the replacing?
Here. So I've got 2 NAs.
Yeah.
I took 1 of them off, so I'm going to leave 1 of them, and I replaced the other with an H.
Okay.
Hunter.
Joe, what'd you do this?
We're going to do some examples from your homework now, so hopefully this will make a little more sense when we get to it.
Well, we had we just soccer game.
Where you should play some
Friday night.
That stinks.
We had to get some rain. And then the other team ended up.
Can we do this whole packet? Not yet.
They're 18. That was not on their roster. So.
All right, so friends, we can do pages 1 and 2 today. Don't worry, this won't take you as long as it looks. All right, let's do a couple of examples from each of the sections so that you know what to do. I'm going to start at number 1. Okay, so so it's really important that you read what the title of the column is so that you know what is expected of you in the next area. But also there are some like example or well, we'll see. Well, I'll show you as we go through. Okay, the first one is H2SO4. What is its conjugate base?
HSO4 minus.
Oh, that's all we have to
Wait,
do.
which one is this one?
This is the first one, number one.
Is that all we have to do?
Yep, for the first two pages, yep. Mason?
The whole page? What is that?
We'll get there.
Is that the whole?
The whole first two pages, yes. All right, now I'm going to skip down to number 4. I'm going to choose some like ones that I think are a little trickier so that you have a start on it. What would be the answer for number 4? HC2O4.
Minus.
Okay, how did we do? Okay. Let's do number 12 together.
No.
What should you get for number 12?
H2PO2 minus.
Is that right? Well, you remove an H and you reduce its charge by 1. So that works. Okay, so then when you get down to a question like 14, you have the conjugate base given to you, but you're asked to find its acid. So what will the answer be for 14? H or no H?
H2 is
SO3 minus or no minus?
oh yes. No minus.
No minus. No minus.
Oh,
All right, let's do 15. Here we have S2O3 minus, 2 minus. What is its conjugate acid? Does that make sense? So when you're going from acid to base, you remove the H. When you're going from base to acid, you add the H. Mason?
Didn't we have a conjugate base of PO4 4 minus? Because on our pink sheet it would be.
What is setting?
It's supposed to be 3 minus. But we have H2PO4 2 minus, which if you break it down all the way would become PO4 4 minus.
Yeah, no, that's a typo. Number 18 is a typo. But still give me the answer like I knew what I was doing.
Would it be H3PO4 minus or H3PO4?
It would be H3PO4 minus.
P31.
Yes, I'd be happy to. But before that, I want to do number 24 first. So on the left-hand side of your page 1, you're given base on the left now and conjugate acid on the right. So just be aware of where you're looking at.
Oh.
So the base is NH3. To make an acid, do you add H's or subtract them? Add. So it would really be H and H3, and then what would be my charge? Correct. Now-
Let's do NH4.
Yes. So the proper way to write this would be NH4 plus. That's more proper. I will not take points off if you write H and H3 plus. If you don't have the plus, it is wrong. I won't give you partial credit either. You have to do both bits. But then Elliot asked for 31. This is an organic carboxylic acid, which you don't need to know, but that's why it's written this way. So how do you make this friend's conjugate acid? Well, what's a how do you make a conjugate acid? You add an H, and then what do you do with its charge? You increase it.
So you don't gotta rearrange it.
Nope. It's written that way because we like to write out how the elements are in space when we do organic chemistry. Yes, Hunter?
So can we put it like H3CO, CO too, or do we have to keep it like that?
I would just keep it like this.
All right.
What else do you want me to look at with you on the fresh page? That seems a little bit more bad. Anything looking rough on page 2? Oh, ooh, I almost forgot. Page 2, friends. Do you see the bit where, like at 85, it says, use a counter ion for the following conjugate bases? Let's do a couple of those so we know what to do. So in that one, again, we've got base on the left, conjugate acid on the right. And the conjugate acid is HOOH, which is hydrogen peroxide. Okay, so what? I'll come back and do that one. Okay, so to make the conjugate base from the acid, what do? Do you take off? Guys, do you take off an H or do you add an H? To find the base. Remove. Okay, so that means I would have OOH minus, I'm sorry. But the instructions tell you to use a conjugate, use your counter ion. So that means that you need to put NA at the beginning. So remember that when you're adding when you're doing the counter ion, all you have to do is replace the H with your counter ion. So for 86 then, I can only do one H though at a time. So I want to replace one of those H's Well, they're electricians.
Oh, it's
We are on their time.
What are they doing?
Well, so we got all of those new hardwares downstairs, and they need different outlets than the ones that are in the room. And you have to have an electrician install all that. Well, it doesn't need to be. And electricians set their own hours because they're so rare that they can. Well, I don't want to work then, so I just don't have to. You can find somebody else if you want to, but they know you can't because there just aren't electricians. So, if you're thinking about a career path and you would like to be a smart person, like if you're a smart person, like you can't be a dummy to be an electrician. So if you're a smart person who just is like, I don't know that I can do another 4 years of school after high school, and then like maybe even more years after that, like I kind of just want to work and I want to like make a decent enough money to like, you know, have a nice lifestyle, I highly recommend electricianing.
I think Jake would be a very good electrician.
Yeah, well, after his little incident in biology, I told him he did not choose electricity. Electricity chose him. So I feel like he's got to be an electrician now.
He was very good in engineering one.
Yeah, he has a natural like ability for it. I mean, my cousin Frank is a journeyman electrician, so that's the one that you like have to pass like the super hard test with all of like the codes. Like you have to know what you're doing. You have to be a smart person for that. Like and so he just passed that test. He's like in his early 20s. He doesn't work for 3 months of the year because he just doesn't want to have to. And he makes twice what I make being a teacher.
Where does he work?
He lives in Fond du Lac, but he he has jobs all over the country, and he chooses which ones he wants, and then if it's like when he really likes to ski, and so if it's like during the winter months he doesn't want to work because he wants to like travel to Colorado and smoke pot and go skiing.
Yes.
That's a lifestyle. I don't know. It's legal there.
He's achieving greatness.
Yes, indeed. Okay, so let's just do a couple more of these.
Next year there's pretty small.
Okay, so remember you're just going to do an even exchange, replacing the H with a counter ion. And now here I feel like maybe using K. Does it matter? No. How do you know which one to choose? You don't. Just pick one.
You're not changing the symbol at all, right?
Nope. Okay, Donovan, what would you want me to do again?
I got it now.
You got it? Okay. Oh, 17, that might be tricky for other people as well. Here's your base. To find your acid, you're just going to slap an H at the end, at the beginning.
Yeah.
And that's it. Okay, so use your noodle on this. You have the whole rest of time as your own.
Now wait a minute.
And then we'll learn how to do the